everyone loves to have superpower, but often this is also comes along with a risk. So that's why we want to have less power. So that's why we do Rootless with Kaniko. Thank you, Martin.
Thank you, Roger. And thanks to all of you to staying here for the last presentation today. My name is Martin Zillmann, and I would like to present Kaniko, the rootless container builds in 2026. But before we start, I have a few questions for you. Two questions, precisely. Who is using GitLab at their workspace? Okay. And who is using Docker Dint on Kubernetes to build Docker images? Not that common as I expected. Well, we do. And actually, it's surprisingly insecure. And why is that? Well, when you run Docker Dint in Kubernetes, you need to give privileged access to the container that is running Dint as a sidecar. And what does privileged access in Kubernetes actually mean? Well, it basically means you give root access to the underlying host. And let me show you that with an example. So I have a Dint runner running here, and I open the interactive terminal. And from here, I can create a new container in the sidecar, which is also running as privileged. And it can actually see all the devices from the underlying host. And worse than that, I can then go on and mount the root file system and read it. So you can see here all the passwords. I redacted them for just to be sure. And worse than that, I can even write to the root file system of the underlying host. And I can inject my SSH key into my good friend Rurik's user account. So now I can log in as Rurik, not Martin, sorry, if you forgot my name. So you can see I'm now Rurik on the server. So how did this exactly work? Maybe it was a bit too fast, but basically we have those two containers. We have the build container where I connect to with interactive terminal. And we have the sidecar, which is running privileged. You can see that by that dashed outline. I tried to symbolize it, which means it's not really that well sandboxed. I can then create another privileged container inside that privileged container, which means you can see there's no real sandboxing to the underlying host. So that's why I can punch through and inject my keys and then connect from the outside. So with that, I hope you're now excited to learn about other methods for building Docker images in Kubernetes more securely, especially for your servers. So the agenda for today, we're going to talk about how Docker actually works and why it needs privileged access. And we do this by building our own poor man's Docker, so just with regular syscalls. Then we will look at Kaniko, how it works under the hood and how it can build Docker images without privileged access. And then we're going to look at three problems symbolized by those dragons. So where the simplified approach to building Docker images breaks down. We're going to have an outlook at the future of rootless builds. And then finally, with what we learned today, we can do some fun stuff. So first off, poor man's Docker. So when you look at what Docker actually is, it's just a nice UX, a nice wrapper around the unshare syscall. Specifically on Linux, you can see that it doesn't work on BSD stack, for example, on BSD. So the unshare syscall also has a nice CLI. So what it does is it creates a new namespace. And you can do this for many things, but here, let's do it just for the processes. 1 second. And you can see that in here, I now have a new PID1 and 2 processes running. But I'm still root. So when I create a process in here and in a new terminal, I search for it, you can see that it's actually running as root. So it's root on the host system. Even though it's isolated from the processes, it's still running as root on the host system. And this is what we usually call a privilege container. So privilege container actually has two parts. So it's a bit more complicated than what I just did. Just to be secure, it needs to have a few more arguments to it, but it's basically doing the same thing. If it works. Okay, now we might have a problem. Yeah, now, okay, just took a while. Okay, and from here, I can then also do dint. So that means I can create a container inside the container. The same means. So now I have this containerization inside. But the problem is, I can also do the trick I did before. I can get the devices, mount the host file system, and read it. And you can see here, the Martin user with the password is visible. So that's the problem with privileged containers. You can punch through to the underlying host. So we have this concept of unprivileged containers. And this is actually what you get in Kubernetes by default. It does the same thing as privileged containers. It does a bit more. Immediately after you open the container, it will drop all the privileges. So you can see we are still root, we're still UID 0, but now the cap sysadmin, cap netadmin, and all those privileges, they're dropped. So you're no longer able to do things with it. Which means now if I try to do the same thing as before and break out of the container, I get permission denied. But the problem is that when I then try to do dint, so create a container inside the container, I also get operation not permitted. So this is also blocked. And this is the cruel irony of cap sysadmin. The same capability that lets you create containers and manage them also lets you escape them. So you can't give that to any job running in Kubernetes. So, but if you take a step back, our goal is not to create containers in containers. Our goal is to have a CI where we have reproducible builds and tests. Our goal is to drive the machine in a state where we can run those tests. And if you work with GitLab, as most of you do, you know that you can write GitLab CI YAML. And conceptually, it's the same as a Docker file. So you can start from some image and you can install stuff in there. There's no caching and things, but the right-hand side works without any privileges. But if you want to do a Docker build, now you need them. So what does GitLab Runner do differently than Docker dint? Well, there's no containerization. In GitLab Runner, it will just execute whatever you tell it as a shell script in its own machine. And that's why it doesn't need any privileges. It just interprets the commands that you give to it. And there comes the idea, can we just write an interpreter that accepts Dockerfile as a syntax instead of GitLab CI YAML? And that's basically what Priya Wadhwa and Dan Lawrence did at Google in 2018. And they thought, oh, this is just a lab experiment. Nobody's ever going to use that. But they released it anyways, and it completely took off because it actually solves a real problem. But then they both left Google to found their own company, ChainGuard. And Google does what Google does best. They archive the project. And that's why we now forked it under OSS Container Tools Kaniko. And with me, I mean myself and 5 maintainers, including Nate, who is here today. That's why I was invited. Yeah. So let's look at how Kaniko works under the hood as the Dockerfile interpreter. Basically, it has 3 parts. We have a parser, an interpreter, and a snapshotter. The parser just reads the Docker file and tries to make sense of it. What is it actually you want to do? The interpreter is just a glorified shell execute. So when you type apk@curl as a run statement, it will literally just shell execute apk@curl. And finally, the snapshotter, before and after each step, it will just look at the file system and see whether there were any files touched. And if there are any differences, it will add them to a layer and finally push them up as an image. And that's all there's to it. It feels kind of like a magic trick because it looks like Kaniko can do what Docker dint does, but without privileges. But it's not a magic trick, it's just an illusion, because nowhere in this process did we use any containerization. But people expect it to work the same as Docker dint, to have the same behavior as something that is giving you this containerization. And because it's just an illusion, it can also then break down. And today we're going to look at 3 cases where this illusion breaks. So first off, a lot of people want to have their own customized Kaniko image where they have some tooling installed to, I don't know, check images, do SBOM, etc., 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 all the things that you need aside from just building. But the problem is you have to understand the image is the application. And if you tamper with the image, you break the application in unexpected ways. And this I will show you here by building our own custom Kaniko image that has Crane pre-installed. And now let's have a look what happens. So we have this payload image that starts from Alpine, and it also tries to install Crane. Let's first build it with official Kaniko. And you can see that when we run Crane version as part of the build, here it will also report 0.21.5. Then when we run the image that we just generated, it has Crane installed also in version 0.21.5, what we would expect. Let's use the custom Kaniko image that we modified before. And here, as part of the build, it will also say Crane 0.21.5. You can see it here. But now let's run the image that we generated. And here we can see Crane was not installed. It's missing from the image. How comes? When we look at the file system state in our custom Kaniko image and in the official Kaniko image, you can see that there are actually folders before the build. There's a BusyBox directory, a Kaniko directory, and in our custom image, there's also the Crane binary there already. So now we start, we say, okay, I want to start from Alpine image. So Kaniko will download the files, download the image, and unroll the folders into the file system. And then Snapshotter will see there's now new files and folders. We'll see the diff, we'll add them to a layer, add them to the image. When we install curl, same thing. It will see a new binary in the file system. It will add it to a layer, add it to the image. The problem is when we install Crane, on the right-hand side, there's no diff in the file system. It was there before. So Snapshotter will not see that. And what will happen is there will be an empty layer added to the image. When we run Crane version as part of the build, obviously both say 21.5 because the Crane binary is there in both cases. But the problem is once we look at the payload image, the one that we created, only what was snapshotted will actually survive. And now Crane is gone because it was never snapshotted. The fix to this is pretty simple. It's just before you start building, just delete the entire file system. And that works perfectly. So now both cases go through. You can restore what you deleted beforehand. After the build, it doesn't matter. The next problem is bootstrapping. So people obviously want to build Kaniko with Kaniko itself, but it's surprisingly not that straightforward. So previously I was using Docker to build our custom Kaniko image. Let me show you what happens when you use Kaniko itself. So the build will work just fine. Take a while. Okay. But then when we actually try to use it and build another image with it, now it says Kaniko executor, no such file or directory. So when we compare the state of the file system again, this time between Docker and Kaniko, you can see that in the case of Docker, there's an empty file system. But in case of Kaniko, we have those two directories, BusyBox and Kaniko there already. So when we start with the Alpine image, both will unroll the files from the image into their file system, into their build environment. Curl installation, no problem. Crane installation, no problem. But now we want to copy the Kaniko folder from the official image into our custom one. And now we have a problem because we have a naming conflict. There was the Kaniko directory already there as part of our build context. And now we want to create one from the official image to as a payload to add. And this will not work. What Kaniko does is it will simply ignore that we want to add that folder. And then the result is there's no Kaniko folder in our resulting image, so you cannot use it for building. Again, the solution is actually simple, trivial. Just rename the folder. Just before you start, just rename it to Kaniko 2 or whatever. It doesn't matter, because now you have no longer a naming conflict. Now you can just copy it over, create your own Kaniko folder there, and it will get snapshotted. And then both work. The last issue we're going to look at today is sandboxing, or the lack thereof. I have this pointless image here. And when I run this in and try to build this in Docker, it will say, obviously, there's no Kaniko folder in a BusyBox image, because why would there be? So the build fails. But let's see what happens when we do the same thing with Kaniko. Now you can see not only is the Kaniko binary there, helper binaries and stuff, the Docker file, but worst of all, our registry credentials. And they're visible from within the build environment. So if you look at conceptually how DINT works, it's able to create that sandbox around your build environment. And the passwords, the registry credentials, and all the build metadata is stored outside in your build context. For Kaniko, there's no differentiation. Build environment and build context are one and the same, they're just merged together. So when you run LSLA Kaniko, you can actually leak that build context in your build environment. So you can see that. Solution here is also possible, or first off, it's a security trade-off. So Docker Dint is able to create that inner sandbox for you to protect the credentials, but in order to make that possible, it needs to run privileged, so it weakens that outer wall. Kaniko keeps that outer wall to your servers intact, but in turn, it's also not able to provide you that inner sandboxing to protect your credentials. So to put it bluntly, Dint protects your passwords while Kaniko protects your servers. But it's actually possible to fix that as well. So the fix is also not that straightforward, but conceptually quite simple. Just don't put any passwords in that pod. You can have a sidecar running alongside that contains all the passwords as a HTTPS proxy, and all your traffic just goes through there, and you don't need any registry credentials. Or you can have short-lived credentials, which don't matter if they get exfiltrated. So it all can be solved. And this is actually the part of the Kaniko's philosophy is you don't try to invent your own security model, try to make this sandboxing work by yourself. You just rely on the fact that you have Kubernetes under you, which protects you. And you try to run properly inside Kubernetes. So you try to run without privileges, etc. But there's still one problem. We're still root. And we're still root on the server. So it's actually not that secure. But here comes the solution. Oh, this one is a bit messed up for the Zoom. But in Kubernetes 136, there's a new option for your pods, which is host users false. And what this does is it maps the root user inside the pod to an arbitrary user outside on the host system. So let's look at that again with our Foreman's Docker. So we can create a container, and this time I pass this option mount root user. And what it does, I'm still privileged. I have cap sysadmin, cap medadmin, and all those. I'm UID 0 inside the container, but actually it's a completely different user outside the container. Let me show you that. So if I run who am I here, it will say you're root. But now let's create a process and check. Here it says no, that process was actually created by Martin. So this is that mapping. And inside that container, we can now create another nested container, no problem. So that works. And if we try to break out, because we're not root on the host file system, it will give us a permission denied. So basically, this resolves the dint issue because you can run both nested containers and not expose your host. So now comes the idea that this will impact the landscape of build tools that we use. And I listed them here in the order of like security, whatever that means. But basically on the top, you have tools like Nix, which run purely in your user space. They run with their own configuration files, etc. But they run as your user, and they run without any privileges. You have Rootless, Podman, and BuildKit, which run rootless, so with regular user. They don't need privileges, but they need certain kernel features enabled so that they can run like this. So it needs changes to the host system. You have Kaniko, regular, Podman, and BuildKit, which run as root, but don't need privileges. And you have Dint, which I showed before, which has that catastrophic combination of being both root and privileged. So what happens with 136 is basically that that first column disappears. It no longer matters whether you're root inside the pod or not, because anyways, on the system, you're just a regular user. Which means if you look, the rootless podman and the regular podman, they now basically have the same security footprint, but rootless podman is a bit harder to set up. So you can think them away. And what remains is actually there's not that much difference anymore between all the different tools. Yes, Dint still sticks out. It needs privileged access. And you could argue that, yeah, it is secure now because it's namespaced, but on the other hand, you still require those features to be implemented correctly in the kernel. And on my books, having no code is the most secure code. So that's what's going to happen. So with that, what we learned today, we can now do some fun stuff because we learned that Kaniko is not necessarily a tool to build Docker images. It's a tool to interpret Docker images as a way to communicate intent. And I will show this with our remote agents. And they're here. So I created a pod here. It's basically just a pod in Kubernetes that runs Claude. And you can see that it's booting into a Ubuntu 26 image. But now, for whatever reason, Claude decides, oh, actually, I would need an Alpine image, for example. Or let's say you have a CI running, and it needs to have access to certain tools, etc. So you now have the choice. I can boot another pod, give my Claude the permissions to create that other pod that then starts another image and then like communicate with that. But actually that's totally excessive because all you need is you need to change your own file system. And with Kaniko, what you can do is it can create a Docker file here. As we said before, the Docker file is just a way to communicate intent. And the Docker file contains the image where you want to start off and other tools that you need. And now the Kaniko that is running inside that pod will wipe the entire file system, and it will try to boot into the other one. And now actually, my shell here is gone, so I have to open a new one. Okay, and now we should be. Oh, can I type? And now we're in Alpine. And you can go back and forth and between different tools without starting new pods, without giving the AI agent permission to start new pods. That's it for the presentation today. It's a bit a shorter one. If you have any questions, now is the time. And also please check out the repo on OSS Container Tools Kaniko. Thank you.
Thank you very much for this informative talk. I really enjoyed it. Now, hypothetically, if I would build a platform as a service, what would you recommend from a security and overhead perspective as a build system or build layer? Also thinking about persistent caches and how that part works. Because what I took away from it is, in the end, just looking at the security layers, it doesn't really matter that much anymore.
Yes, you're right in that regard. So BuildPack actually supports Kaniko as well as a build tool. So you would be fine to select this as an option. But fundamentally, Docker build is remote code execution as a service. So the security will only protect your servers underneath. So if you run it in an environment where you don't care much about the servers, then you can use whatever tool that you want. And otherwise, I would try to stick to the one that gives you the most security. And until 136, you saw the list before, there's a bit more differentiation. After 136, there will be hardly any differentiation between the tools.
So, hi. Thanks for the information how to build Kaniko with Kaniko, because I tried that for, I think, a complete business day and had to do a rec-CTL crane and all kind of dark magic to actually make it work. But now to the real question, I have little clue about Go. How can we still support, or how can persons like me still support you with the fork of Kaniko?
I mean, it's support already if you spread the message that this fork exists. If we can get more people to use and embrace it, that's already help enough. And of course, help creating issues. If you face problems like this, I'm happy here to help. Also, Nate's happy to help to answer questions. And then, of course, pull requests. We're not yet flooded, so that's fine.
I think actually one of the first contributions to this fork was from Siemens, so keep doing that.
Thank you. Yeah.
Hi. For your thing using Claude that would then use Kaniko to switch to another container image, pretty much like another file system, what would be the difference if you were to use Podman Run, like having Claude just using Podman Run?
I think there will be not much difference, except that it will be in a container inside. Here it's on the host file system directly.
Okay, thank you.
So first of all, thank you for taking on the Kaniko project. We use it since years, and it's really cool that we can continue using the project. My question is about the Kaniko build. We moved the directory, right? So does this also create a layer where now we have two?
No.
Why not?
So the Kaniko folder, which is your build context, is always ignored. That's why when we saw before, if you try to create a file in there, or if you try to create a new folder, it will not be snapshotted. The snapshotter is aware that this folder should not be touched. And so when you then move it to another name, this happens before the build, and the snapshotter is aware of this new location. So it will not get snapshotted.
Okay, thank you.
A question from Felix from the chat. Is it possible to build a bit-by-bit reproducible image with Kaniko?
Yes.
Yeah, thanks for the presentation. I was just looking at Kaniko replacement on Google, and he's proposed me a lot of different options, and also a fork from Chainguards.
From Chainguard, yes.
Yes. So what is the difference between your fork and their fork?
So I said before, the original authors of Kaniko, Priya Wadhwa and Dan Lawrence, they founded their own company, Chainguard. And when Google archived the project, they said, we as the original authors, we're gonna create a fork where we can do LTS support on it. But of course, them being CEO and CTO, I think now, they don't have the time to actually fix bugs, add new features, etc. So the Chainguard fork does literally just updates to the dependencies. So when there's CVEs in any dependencies, they will update them, but they will not do bug fixes, improvements to caching, etc., etc., etc. So that's why it's maintained, but more of an end-of-life support on their end.
Do you have like cross contribution between two forks? Or?
Unfortunately, no, they closed their fork for contributions.
Then I would say thank you very, very much for maintaining Kaniko and this insight.